we're going to look at a couple of unit analysis problems. Now, the tip for converting units is to start by writing the quantity in original units and then multiply by a fraction equal to 1 so that the units you want to eliminate appear in one numerator and one denominator. Okay. Now, while I am looking at any of these unit analysis problems, I'm also going to want to look at the conversion facts for unit analysis file. So I'm going to open that right now to get a look at what that looks like. Okay, so my conversion facts for unit analysis really just contains some basic conversions. Some of them we already know, conversions that are in the English system, like 1 foot is the same as 12 inches, but there are a lot of ones that convert from the English system to the metric system that we're not expected to know or remember, so we need to have this file to be able to look those up. Okay. If we scroll down a little bit in this file, you'll see some other ones that may come in handy later on. So just we'll keep this available. All right, let me tab back. Okay, so I'm going to look at this first example here, and we're looking at as of 2010, the tallest man-made structure was this building I've got a picture of right here, and it was, or it is, 828 meters tall. So I want to know how tall this skyscraper is in feet. Okay, so to convert between meters and feet, my first step is going to be to write the quantity in original units. So I'm writing down my 828 meters. Okay, now what I want to do is multiply this by a fraction. I just don't know yet what fraction I want. So I'm going to have to look up a conversion fact that's going to connect meters and feet. Okay, so let me look back on the other side. Okay. Feet and inches, okay, those are all American. I want American to metric. So inches, centimeters, feet, meters. Looks like I want this one right here to convert feet into meters. 1 foot is 0.3048 meters. Okay, notice while I'm looking at this sheet right here, the abbreviation M will always stand for meters. If I wanted the abbreviation for mile, it would be MI, not plain M. So if I have miles later on, by the way, just making a note that this is always going to be an M for meter. MI would stand for mile. Okay, so back to writing my fraction. I need to think about this right here is also a fraction over 1. Any number, any whole number can be written as a fraction with a 1 in the denominator. So what that does is show me that the M for meters in the original is really in the numerator, and I need to make sure that I have one M in the numerator and 1 in the denominator. So in my conversion fact, I'm going to need to write the number of meters in the denominator. So that number again was 0.3048 meters. 0.3048. Okay, 0.3048 meters was equal to 1 foot. Okay, so if I have that conversion fact, I can cancel my meters because in a fraction, when you have something in the numerator and something in the denominator, in a multiplication problem, those will cancel. And when I multiply these together, we're going to multiply straight across. 828 times 1 is 828 feet, divided by 1 times 0.3048. Alright, and then we want to finish that division to see what we have. So we're taking 828 divided by 0.3048. We come up with 2,716.5. Let's just round at the tenths place right here. Okay. So the tallest man-made structure as of 2010 is 2,716.5 feet. Okay, so we've converted that from meters to feet. Alright, so let's look at another example. We can see the one below just starting to pop up. It's about red meat production in Iowa. That's 585 million pounds per year, and I want to know how many ounces per day we're talking about. Okay, so the first step is to write the units on what I'm talking about. Now I'm going to write that we want to be looking at 585 million pounds per year. Now I'm going to actually keep million aside as one of the units. I don't actually want to write out all of the zeros for 585 million. So I'm going to just say that millions is one of my units. And so I'm going to hold on to that one for a second because I'm going to just make sure I put my unit in ounces and millions of ounces. So I'm going to write this down. I'm going to go for 585 pounds. LB is the abbreviation for pounds per year. Per again, per is one of those words we use for division, so I'm using a division bar for the word per. Okay. Now we're going to multiply this by a certain fraction. I need to go from pounds first into ounces. So I need to know how many ounces there are in a pound. Okay. So there are 1 pound is equal to 16 ounces. Okay, so there are going to be 16 ounces in a pound. All right, so pound is on the top of this fraction, so pound needs to be in the bottom of this fraction, and 1 pound was equal to, in this case, 1 pound is equal to 16 ounces. So that's going to allow me to cancel pounds, and now my units are ounces per year. Okay, we need to keep going. This one's going to require another conversion because I need to convert years into day. Now, this fact I could look on my sheet, not on my sheet though. So I know common knowledge tells me how many days are in a year. So years on the bottom in this case, that means that year has to be the unit on the top of this fraction. So 1 year is equal to 365 days. Okay. And again, that's going to allow year and year to cancel, one on top, one on bottom. And I'm going to finish my multiplication. Multiply the top numbers together, multiply the bottom numbers together, and we're going to end up in ounces per day. Now remember, we're in millions of ounces per day, so we're going to write that part in the end. Okay, so first I need 585 times, times 16. 9,360. Okay, ounces per 365 day. Okay, so let me divide that 9,360 by 365. Okay, so 25, and I'll just join to the 10th again, so 25.6 is going to be my answer right here. My answer is 5.6. Now I'm going to stick in my million. So million ounces per day. Okay, so that's my answer to this one. Okay. So there were 2 conversions we had to do in this one, and one of them we were expected to know without it being on the sheet. There's a couple of those, like how many minutes are in an hour, etc., that are pretty common knowledge. Oops, looks like my words went off the screen right here. You can't see ounces, it's off of your screen. So million, let me stick ounces right over here per day. There, that should all be on your screen now. Sorry about that. Okay. Part C then. In this one, we've got a driver that's traveling 50 miles per hour. What's the driver's speed in meters per second? A lot of speeds are given in meters per second in applications. So let's try to convert miles per hour into meters per second. So I'm going to start by writing 50, and again, I'm using MI for miles, per is that division line, hour. Now, per hour is the same thing as per 1 hour, so if I'd like, I can write a 1 there. And I'm going to convert this. Now I need to do miles into meters. Let's see what we can get here. Miles, oops, that's the wrong page. Alright, there we go. So I need miles into meter. Now I've got miles into kilometer, so I'm going to do that one right here. Miles into kilometer. Then we're going to have to go from kilometers into meters. So 1 mile is 1.6093 kilometers. Okay, so 1 mile, again mile is 1.6093 kilometers. And again, I can see miles and miles cancel, so those are in the right places. Multiply by how many kilometers are in a meter. Okay, if I go down to the bottom of this page, it's a reminder of how metric bases work. So my kilometers right here, meters would be a metric base. Meters, liters, and grams are metric bases. And so it would be 1, 2, 3 decimal places to the right, or 10, 100, 1,000. So there are 1,000 meters in a kilometer. Okay, so I'm going to put 1 kilometer, bottom again because that was on the top, equal to 1,000 meters. Okay, so 1 kilometer, kilometer and kilometer cancel, now my units are in meters. Okay, so altogether I want meters per second. So far I've got into meters. Now I'm going to go change hours into seconds. First, I need to change hours into minutes. So I'm going to multiply by, let's see, 1 hour on the bottom, so I'm going to put 1 hour on the top. And 1 hour is equal to 60 minutes. Okay, so that would see hours canceling. Alright, and then I need to do 1 minute is equal to 60 seconds. Okay, and that's going to have minutes canceling. Okay, so my units all together right now, across the top, the only unit I have is meters. Across the bottom, I only have seconds. So it's meters per second. Okay, all I need to do now is finish the multiplication on this. Multiply all the numbers on the top, divide by all the numbers on the bottom. I have a lot of room, so I'm just going to get the answer all in one line. So let me go back to my calculator. Okay, so to multiply all the numbers on the top, 50 times 1.6093 times 1,000. Okay, I'm going to go ahead and hit divide by 60. Divide again by 60. Let me fix that real quick. I accidentally hit the plus key. Okay, I got it typed in there better this time. So 50 times 1.6039 times 1,000, divide by 60, divide by 60. When I hit enter, it's going to compute the entire answer here. So 22.35, so let me round that to 22.4. So 22.4, and my units are meters per second. Okay, so it is possible to type it all in one line. We need to be a little bit careful though about, well, I had the wrong key, and just making sure that we use divide by 60 again, because I've got two 60s in the denominator. Okay, it's much safer to multiply all the top numbers and all the bottom numbers. So I would do that if you're not feeling comfortable with what I had just done. Okay, all right. I'm going to set this last one up. So let's see. A nurse has on hand 500 milligrams of morphine in 500 milliliters of normal saline. She needs to administer morphine 80 milligrams per hour in a continuous IV infusion to a patient with terminal cancer. How many milliliters per hour should she set in the controller? Okay. So we're going to start off with what she needs to deliver. Now, in this case, it's not the first number in the problem. She needs to give 80 milligrams per hour. So that's going to come first. And we want to see where we're trying to get to. We want to get to milliliters per hour. So actually, hours is fine. It's just we want to turn milligrams into milliliters. Now, normally, since milligrams is a measurement of mass and milliliters is a measurement of volume, you can't convert from one to another. But I've been told that I've got 500 milligrams of this drug diluted into 500 milliliters of saline. So this right here is a special, and it's hard to read right now, but it's a special conversion fact just for this problem. And that allows me to take my milligrams and cancel them. And, well, 500 divided by 500 is 1. So my answer to this one right here is 80 milliliters per hour. Okay, just canceling those as well. And my units are milliliters per hour. This example right here is, it's really given because some problems like this one have a special conversion fact. You need to figure out how to use that. And identifying what the important bits of this kind of situation are.